On August 25, 2017, a tropical cyclone made landfall on the central Texas coast during the final week of the Atlantic hurricane season's peak activity period. Southeast Texas, including the Houston metropolitan area, operated under standard late summer conditions, bayou networks designed for drainage rates based on historical rainfall patterns, 2 federal reservoir systems maintaining normal pool levels, and urban infrastructure scaled to accommodate typical tropical system passage times of 24 to 48 hours. The region's flat coastal plain topography, with elevation gradients measuring less than 1 foot per mile in many areas, relied on continuous drainage flow to prevent accumulation. Standard forecasting models projected the system would traverse inland and dissipate within the expected time frame for Gulf Coast tropical cyclones. The Houston metropolitan area occupied approximately 10,000 square miles of Gulf Coast prairie, with the urban core situated 50 miles inland at elevations ranging from 40 to 100 feet above sea level. The region contained 4 major bayou systems: Buffalo, White Oak, Brays, and Greens, engineered as primary drainage channels feeding into the Houston Ship Channel and Galveston Bay. 2 federal flood control reservoirs, Addicks and Barker, were constructed in the 1940s on the western perimeter to capture runoff from upstream watersheds covering 150 square miles. The reservoirs operated with maximum design pool elevations and controlled release rates calibrated to downstream channel capacity. The drainage infrastructure was designed using rainfall probability models derived from 20th century precipitation records, with design storms typically not exceeding 15 inches over multi-bay periods. Tropical Storm Harvey formed in the central Atlantic on August 13, 2017, degrading to a tropical wave before regenerating in the Bay of Campeche on August 23. Rapid intensification occurred over warm Gulf waters, with sea surface temperatures exceeding 86 degrees Fahrenheit. The system achieved Category 4 status with maximum sustained winds of 130 miles per hour before making landfall near Rockport, Texas at 10 p.m. on August 25. Initial landfall impact affected a 40-mile coastal segment with storm surge reaching 6 to 10 feet and wind damage concentrated in a narrow band. Standard cyclone behavior would have resulted in the system weakening rapidly and tracking northeast into Louisiana within 36 hours, maintaining forward motion between 10 and 15 miles per hour across the region. Following landfall, Harvey's forward motion decelerated to between 2 and 5 miles per hour as steering currents in the mid-troposphere collapsed. A high-pressure ridge positioned over the central United States blocked the typical northeast progression path, while weak atmospheric flow patterns provided insufficient force to move the tropical circulation. The system drifted southeast back over Matagorda Bay on August 26, then stalled in a position 30 to 50 miles offshore, maintaining tropical storm intensity with sustained winds near 45 miles per hour. This configuration persisted for 4 days, with the cyclone's outer rain bands rotating continuously over the same geographic area. Moisture convergence from the Gulf of Mexico fed persistent convective cells that regenerated over southeast Texas at intervals measured in hours rather than the typical single-pass time frame. Rainfall accumulation began exceeding design thresholds within 24 hours of initial landfall. The National Weather Service rain gauge at Marys Creek in southeast Houston recorded 9.92 inches on August 26th, followed by 13.84 inches on August 27th. On August 27th alone, multiple gauges recorded single-day totals exceeding 15 inches, with some locations measuring over 20 inches in 24 hours. The 4-day accumulation from August 26th through August 29th produced maximum recorded totals of 60.58 inches at Cedar Bayou in Chambers County and 49.32 inches near Mont Belvieu. Over 8,000 square miles received more than 30 inches of rain. Rainfall rates sustained at 2 to 3 inches per hour for extended periods overwhelmed soil infiltration capacity within the first 12 hours, converting all subsequent precipitation directly to surface runoff. Bayou systems exceeded bank-full capacity by August 27th. Buffalo Bayou, with a normal channel width of 200 feet and depth of 15 feet, expanded to over 2,000 feet wide in sections, submerging adjacent parkland and approaching the foundation level of downtown structures. Addicks and Barker reservoirs received inflow volumes 15 times greater than design capacity, with pool levels rising 8 to 12 feet above normal within 48 hours. On August 28th, controlled releases were initiated at maximum safe rates of 4,000 and 7,600 cubic feet per second, respectively, flooding approximately 10,000 homes immediately downstream in the energy corridor and memorial areas. Uncontrolled releases would have risked earthen dam overtopping and catastrophic structural failure. The reservoirs remained above normal pool elevation for 3 weeks following peak inflow. Interstate 10, Interstate 45, and U.S. Highway 59 became impassable through Houston by August 27th as water depths exceeded 4 feet across multiple segments. The 610 Loop and Beltway 8 experienced complete closures at bayou crossings, severing circular routing around the metropolitan core. Over 1,000 road segments were closed simultaneously, fragmenting the transportation network into isolated cells. Emergency vehicle access to medical facilities was restricted to helicopter transport in areas where conventional routing was eliminated. George Bush Intercontinental Airport suspended all operations from August 27th through August 29th. The Port of Houston Ship Channel remained closed for 5 days. Total road inundation affected approximately 300 square miles of the urban area, with water depths exceeding 10 feet in localized depressions and along primary drainage corridors. CenterPoint Energy reported 109,000 customer outages at peak on August 27th, concentrated in areas where floodwater reached electrical distribution equipment and substations. Wastewater treatment capacity was reduced by 40% as 39 of 97 lift stations in the City of Houston system lost power or were submerged. Approximately 40,000 structures experienced sewage backflow as sanitary systems were overwhelmed by infiltration and inflow. Drinking water treatment plants maintained operation, but 2 million residents were placed under boil water notices due to distribution system depressurization and potential contamination from cross-connections. Telecommunications infrastructure experienced degraded service in flooded areas as backup power systems at cell sites exhausted fuel supplies after 48 to 72 hours of commercial power interruption. The flooding displaced approximately 30,000 residents to temporary shelters, with over 200,000 structures damaged throughout the affected region. The Harris County Flood Control District estimated 154,170 structures flooded in Harris County alone, representing 15% of the county's housing stock. Emergency response agencies conducted over 17,000 water rescues using boats and high-clearance vehicles. The Texas Department of State Health Services recorded 68 direct deaths attributable to the storm, with drowning accounting for the majority of fatalities. An additional 35 indirect deaths resulted from post-storm complications, including carbon monoxide poisoning from portable generators, traffic accidents during evacuation, and medical emergencies during periods of restricted emergency access. Floodwaters persisted above street level for 7 to 10 days in the most severely affected neighborhoods, preventing resident return and damage assessment. Water recession from peak flood levels began September 1 as rainfall ceased and drainage systems processed accumulated volume at maximum capacity rates. Bayou levels returned to normal banks by September 5, though localized ponding in blocked drainage areas persisted for an additional week. Debris removal operations extracted 8 million cubic yards of flood-damaged materials from the public right-of-way over a 6-month period. The Federal Emergency Management Agency conducted damage assessments for 781,000 housing units and approved 376,000 applications for individual assistance programs. Infrastructure restoration included replacement of 84,000 damaged vehicles, repair of 1,200 road segments, and remediation of approximately 600 contaminated sites where floodwaters mobilized industrial materials or sewage. Full restoration of damaged residential structures required 18 to 36 months in areas where flooding exceeded foundation slab elevation. The National Weather Service designated Harvey as the most significant tropical cyclone rainfall event in United States recorded history, surpassing the previous record of 52 inches set by Tropical Storm Amelia in 1978. The 4-day rainfall total of 60.58 inches exceeded the annual average precipitation for Houston by a factor of 1.2. The National Hurricane Center estimated economic losses at $125 billion, making Harvey the second costliest natural disaster in U.S. history after Hurricane Katrina. The Harris County Flood Control District's post-storm analysis identified that 70% of flooded structures were located outside the 100-year floodplain, as defined by existing Federal Emergency Management Agency maps, indicating that existing probability models did not account for rainfall events of Harvey's duration and intensity. Subsequent hydrological studies recalculated design storm parameters for the region using updated precipitation frequency estimates.